Welcome back, viewers on YouTube. In this video tutorial, we are going to consider going through tons of problems involving the use of the quotient tool of derivatives to solve calculus problem. So let's begin with number 1. Consider the function y that is equals to 1 plus x squared all divided by 1 minus x squared. So how can we determine the y dx by using the quotient tool? Feel free to pause the video and try this question out. After that, you can unpause it to see if you got the answer right. So let's take the quotient tool. It says that, so I'm going to write that at somewhere around there, that the y dx is equal to the first or the function at the denominator, that's v times the u dx, as the derivative of the first one, at the numerator, the minus u dv dx, then everything entirely is divided by v all squared. So the first function, the one you are having at your numerator, is the one you will represent as u, while the one at the denominator will be the one that will be v. So now if u is equal to 1 plus x squared, then what will be the u dx? So this is a constant and its derivative is 0, and the derivative of x squared is simply 2x. The 2 will come to the front and we subtract 1. So we have 2x, and therefore the u dx is simply 2x. Perfect. Now we also said that v is equal to 1 minus x squared. So what will now be the v dx? Which simply means the derivative of v with respect to x. So 1 is a constant and that becomes 0, and the derivative of negative x squared gives us negative 2x. So we have everything we need to get the derivative of this entire function. So therefore the y dx for this function will now be equals to v, which is the function we are having right here, 1 minus x. Since it's a binomial, let me put it in bracket, 1 minus x squared. Then multiply by the u dx, and we got that to be 2x. So times 2x. Then we have the minus sign. Now again we have u, which is this function at the numerator. Put that in the bracket since it's a binomial, 1 plus x squared. Then it's multiplied by the v dx, that gives us negative 2x. So I'm putting that within, okay, let me just write it like that, minus 2x. Then notice that everything entirely is divided by v squared, and v is 1 minus x squared, all squared. Okay. So you can simplify at this point, but sometimes, most especially if you are dealing with multiple choice question, it will depend on how the answer is given. You understand? If it is left this way, fine, you select your answer, and if it is expand, then you move on. But in this video, I'm going to make sure I simplify the answers to the least value or to the lowest term. So the y dx will now be equals to, so I'm distributing 2x for the term within the parentheses. So we have 2x minus 2x cubed, then the minus sign we have here, then I'm still going to put that in bracket, and I'm distributing this negative sign as well. Okay, so I have minus 2x, then minus 2x cubed again. Perfect. Then we still have a division of 1 minus x squared all divided, all raised to power 2. Okay, now excuse me. Now we have the y dx to be equals, so I'm distributing this minus sign to expand this bracket. So therefore we have 2x minus 2x cubed minus times minus 2, that gives us plus 2x, also minus times minus 2x cubed, that gives us positive 2x cubed. and we still have a division of 1 minus x squared or squared. Okay, perfect. Now finally, the y dx becomes, now notice that negative 2x cubed cancels, and we are left over with 2x plus 2x. Okay, so the negative 2x cubed cancels the positive 2x cubed. So therefore we have 4x left over the numerator, and the denominator is 1 minus x squared or squared. So this is our final answer to the first problem, and that's the derivative of the function using the quotient tool. Now on to example number 2. By now you should have been getting used to the logic. Consider the function y that is equal to 2 plus x, then entirely divided by x squared plus 2x plus 7. So what would be the y dx? Okay, don't forget the quotient tool. Okay, let me try and write it here without getting rid of it anymore. So the y dx is v du dx minus u dv dx entirely divided by v squared. So like we said earlier, the function at the top is u, while the one at the bottom is v. So therefore, if u is equal to x 2 plus x or x plus 2, then what would be the u dx? Well, this is a constant, it becomes 0, and the derivative of x gives us 1. Okay, and just like x is power 1, when the 1 comes to the front, we subtract 1 again, and we have 1 times x is power 0, which is 1 times 1, which gives us 1. So that is how derivative becomes 1. Okay, perfect. Now also we said v is equal to x squared plus 2x plus 7. Now what would be the v dx? Notice that in this case we have x squared, which its derivative will be 2x. Then we also have positive 2, which its derivative will be positive 2. And 7 is a constant, it becomes 0. So the derivative of v with respect to x is 2x plus 2. So let's move on. Now we can begin the substitution into the quotient formula. So therefore, the y dx will now be equals to v, which is the entire trinomial. We have x squared plus 2x plus 7, then multiply by, and do that again, the u dx. So the u dx, we got that to be 1. Just times 1. Should I write that? No, I don't know that, because this times 1 gives us back. So I'm just writing the subtraction sign. Then u is 2 plus x. Okay, that's it right here. So we have 2 plus x is a binomial. Let's put that in the bracket. Then the v dx, that gives us 2x plus 2. So we still have 2x plus 2 in the bracket, and entirely we have a division of v squared. So we are squaring the trinomial. So we have x squared plus 2x plus 7 all squared. Perfect. Now let's expand, let's simplify. We have the y dx. Since this nothing is multiplying it except 1, we can just write it out. X squared plus 2x plus 7. Now before we distribute this minus, let's expand these two binomial first. So we have minus, let me do that again so that I can see that properly. The minus in the bracket, 2 times 2x gives us 4x, and 2 times 2 gives us positive 4. And again, x times 2x gives us 2x squared. And finally, 2 times x gives us 2x. Okay, then we still have a division of x squared plus 2x plus 7 plus 7 all squared. Perfect. Now finally, not really final actually, we have x squared plus 2x plus 7. Then the minus sign, we can distribute that, but before I do that, I'm going to combine this. That's just 6x, okay, 6x. So I'm having minus 4 minus 2x squared and minus 6x. So I've added 4x and 2x together. Then we still have a division of x squared plus 2x plus 7 all squared. Okay. Now we can proceed forward with our simplification. So now we have the y dx to be equals. Now, can we cancel out some like terms? Notice that we can. X squared and negative 2x squared gives us negative x squared. Also, plus 2x minus 6x. That gives us minus 4x. Then plus 7 minus 4 gives us plus 3. Good. Then we have a division of x squared plus 2x plus 7 all squared. And this is our final answer at this point. Because if we say we should factorize this, likewise this, they won't cancel that. Okay, as they won't have any like terms present. So that's just it. Now on to example number 3. Feel free to pause the video and figure this question number 3 out yourself. Also, if you haven't subscribed to the channel, feel free to subscribe. And if you're enjoying the video, you can leave a like. Thank you. Consider the function y that is equal to 3 plus 2x minus x squared all divided by the root of 1 plus x. Good. Find the y dx. I said I'm not going to get it with the y dx. I've got it with it. The y dx is equal to v du. Some textbooks used to write it as this, minus u dv divided by v squared. The u means the derivative of u with respect to x, okay? And the v means the derivative of v with respect to x. Keep that in mind, okay? Just to reduce the compassonality, okay? Perfect. Now, as we have been doing, u is this and v is this. Now, you have to be careful with questions like this, okay? Now, if u is equal to 3 plus 2x minus x squared, then what would be the u dx? The u dx will simply be x minus 2x. So 3 is a constant and its derivative becomes 0. Positive 2x, its derivative becomes 2. Oops, I wrote x. Its derivative becomes 2, and then the derivative of negative x squared gives us negative 2x. Perfect. Okay, the 2 comes to the front and we subtract 1. Now, what about v? V is equal to the root of 1 plus x. You notice that v is a function of a function. Okay, it consists of 2 functions. Now, to split this function and to differentiate v with respect to s in the very best possible way, we are going to make another substitution for v. So instead, can we say w is equal to 1 plus x? And if that is the case, then v will now become the root of w. Now, it's easy for us to differentiate w with respect to x, and also along the way differentiate v with respect to w. And at the end, we can use the chain rule to get the v dx. So now let's differentiate w with respect to x. So what would be the w dx? Since w is 1 plus x, then the derivative of w with respect to x will simply be 1. The derivative of 1 is 0 as a constant, and the derivative of positive x is simply 1. Perfect. Now, from our knowledge in indices, the root of w is w to the power of half. So differentiating v with respect to w is simply half w raised to the half minus 1. So the half has come to the front, and I'm subtracting right now. Perfect. Now simplifying this forward, we got half multiplied by w to the power of negative half, because half minus 1 gives us negative half. And this is simplified to the simpler form as 1 over 2 times 1 over root of w, which is simply 1 over 2 root w. Perfect. So now we have the w dx and the v dw. It's easy to determine the v dx, the derivative of v with respect to x, by the use of chain rule. The v dx, let me use different color. According to chain rule, the v dx will be equals to the w dx times the v the w. Perfect. And this is equal the w dx, that is simply 1, times the v dw, that's this, times 1 over 2w. And this is equal to 1 over 2 root w. Now don't forget, we said we differentiate v with respect to x and not with w. So therefore, w must be replaced back with what it is in terms of x. So that will be simply equals to 1 over 2 root 1 plus x. And that is the v dx. So right now, what I will do is that I'm going to get rid of w and then write the v dx to be equals to 1 over 2 root 1 plus x. Perfect. Now, other things can we get rid of now? I think at this point we are good to go on finding the y dx. So according to quotient 2 right now, the y dx will now be equals to v, which is this entirely the root of 1 plus x, then multiply by the u dx. The u dx, we got that to be 2 minus 2x. So I'm putting that in brackets, 2 minus 2x. The minus u is a trinomial, so let that be in bracket as well. 3 plus 2x minus x squared. Okay, then multiply by the v dx. Oops, this won't be enough. I need to adjust the space. Okay. Alright. Perfect. So continuing, we have the v dx. We said that is equal to this. So multiply by 1 over 2 root 1 plus x. Then we have a division of v squared. That's the root of 1 plus x all squared. Okay. Now the y dx will now be equals to, so I would like to combine the fractions at the numerator, you can see. Okay, if I should rewrite that, we will have it as the root of 1 plus x times 2 minus 2x divided by 1, then minus 3 plus 2x minus x squared divided by 2 root 1 plus x. And entirely, we have, since the root can cancel the square, you can just have 1 plus x left over. Now you might be wondering, why am I putting this in a bracket? Well, it's all because of the negative, as it has to take effect. So let's continue. Now I want to combine the fraction at the numerator. The y dx will now be equals to, so let's combine this. The LCM will be 2 with x, 2 with 1 plus x. So if the LCM is 2 with 1 plus x, so 1 in 2 with 1 plus x gives us 2 with 1 plus x, and we multiply with this entirely, we have 2 root 1 plus x times this one entirely, that's 2 minus 2x, then again times the root of 1 plus x. Okay, so we have the division. Okay, then we have the minus sign. 2 root 1 plus x in 2 root 1 plus x gives us 1, and if we multiply with this, we have 3 minus 2x minus x squared. Okay, do not forget we still have a big division of 1 plus x. So instead I will just write it as multiply by 1 over 1 plus x. Okay, so I've used the method of keep change and flip. I don't want to make it to occupy space, that's why I'm putting it beside it. Okay, put it beside it. Okay, now we have the y dx to be equals, so now let's multiply this. The root of 1 plus x times the root of 1 plus x gives us 1 plus x. So we have 2 multiplied by 1 plus x, again multiplied by 2 minus 2x, then minus 3 minus 2x minus x squared, all divided by 2 root x, or 2 root 1 plus x, times 1 plus x. Okay, now before I move on, some of you might be wondering why the root of 1 plus x is equal to the root of 1 plus x. So times their product is just 1 plus x. So let me show you right now. Okay, now the root of 1 plus x, you need to agree that it is the same as 1 plus x to the power of half. So if that is the case, we are multiplying it by itself 2 times. Times again, 1 plus x to the power of half. And from indices, we can take one of the base, 1 plus x, and add the power, that's half plus half. And that gives us 1. Then we have 1 plus x is power 1, which is the same as 1 plus x. So that's how I got the 1 plus x. Okay, perfect. So now we can continue. Now the y dx will now be equals to, so let's distribute. Before I distribute these 2 outside, let me expand the binomials first. So we have 2 multiplied by 1 times 2 gives us 2, and 1 times negative 2x gives us negative 2x. Again, we have positive 2x, and again, we have positive 2x squared. Negative 2x squared, because plus x times minus 2x is simply minus 2x squared. Then we still have the minus. Let me distribute the minus direct. Minus 3 plus 2x plus x squared. You know, minus times minus plus, minus again times minus plus. Perfect. Now we have divided by. So we are going to apply some of the indices law to this as well. So let's just have 2 multiplied by 1 plus x goes to the power of half times 1 plus x goes to the power of 1. Good. So now the y dx will be equals to, so I'm distributing these 2 right now. But don't forget this will cancel out. Okay, they cancel out, they negate themselves. Now 2 times 2 gives us 4. Again, we have 2 times minus 2x squared gives us minus 4x squared. Then we have minus 3 plus 2x plus x squared, all divided by. So I'm applying the indices to this point right now. Okay, I'm applying the indices. That will be 2. Then I'm taking one of them, 1 plus x, all the way to the power of half plus 1. Perfect. So we have half plus 1. So this will be equals. Now 4 minus 3 gives us 1. Also, negative 4x squared plus x squared gives us negative 3x squared, then plus 2x. Again, we are left with plus 1. So this is divided by 2 multiplied by 1 plus x. So half plus 1 is simply 3 over 2. And at this point, we have our final answer to this problem. And that is the final solution to this question. If you have any questions, feel free to let me know in the comment section below. I hope by now you can now apply the quotient tool to calculus problems involving the using of it. So let's consider our last example for this video. Well, I said example. I actually want to say exercise. So this is your exercise. Feel free to share your solution with me in the comment section below. Consider the function y that is equal to the cube root of 1 plus 3x all squared and entirely divided by x. So feel free to share your solution through the comment section below. Thank you. See you in the next class. Or see you in the next video. Bye for now.